All right, let's do this. Let's do this. Oh, guys, this is going to be good. It's going to be real good because my new station's all set up. It's all set up, guys. This is going to be fantastic. All right, let's minimize this. And tools. Yep, sorry, guys. I am just setting everything up here so that I can see what I'm doing while I'm over there. I spent so much time and energy and effort into making my streaming and broadcasting section as current and as functional as possible that unfortunately I didn't set up my cameras for over there, so I'm gonna have to do a little bit of quick this fighting the camera. Oh, I love it. Okay. Okay, the gimbal on this camera is a little weird. There we go. All right, let's go ahead and shut that off. Got you. All right, guys. So, anyway, I have, obviously, I'm always working on some things, and what I also have is the HTM Workshop ECG kit number 2. So, last time we put together the ECG patient simulator, and this time we are going to put together the ECG reader. So that's the patient simulator. Pretty cool. I have no idea how it's supposed to function, but fortunately, there's instructions. So a lot of care was put into this thing, to the fact that you have step-by-step instructions. I mean, you have BOM, bill of materials. I mean, just everything. It's fantastic. I love these kits. And the more time I spend with these kits, the more I appreciate the effort that went into them. All right. When you first open it up, you're like, wow, this is a pretty good kit. But after you open it up and go through some of the stuff, including the builds, you realize this is top notch. Absolutely top notch. So let's see. I do have, well, I don't know if I can show it well enough there, but I did install all of my soldering stations over here. They're screwed down to the bench, so they're not going to tip over, because that's a problem, y'all. So every single one of these, when they're docked, they can sense that they're docked, and they go into a standby. So every single one of them, which is awesome. And they're all kind of set off to the side at an angle so that I can grab them when I need them. So my soldering pencil, I can do whatever I need to. I can reach way over here to do soldering, which is more than enough. I mean, look at that. That's plenty. And I can put it back in the dock. I'm good, you know. One of the biggest problems I was going to have was with the Quick, the 8610. That's because that's the 861 DW. So the Quick hot air station was definitely going to be an issue, because the tube right here is what blows the air. So the turbine is in the base, and the tube is only so long, because the longer it is, the harder it is to get air to the gun at the end. But that is one of the best hot air stations I've ever used, and I'm very excited that now it's hooked up. I did some other things. Like before, everything on this front wall was on one circuit. So what I did is I have a circuit tracer, and I found another outlet that is over on that wall. There's only one other outlet on that wall, and it is on a separate circuit. And I was able to put all my soldering gear over here on a separate circuit from everything here. Because as you can imagine, a computer and whatever else I might be working with on these power strips should probably be on a separate circuit than, you know, the switch mode power supply or the hot air station or something, because, you know, they draw a lot of current. So anyway, guys, I have that all set up. I brought my microscope in. This is my boom microscope. So I have my digital microscope, I have my boom microscope, and I had a little bit of a situation, a little configuration error here, because I love my boom microscope. There is nothing like working with this guy. Yes, the digital microscope, it can do the same thing. It's not the same. If you're manipulating fine parts, there's nothing like the boom microscope because you have a binocular vision. It's fantastic. But the digital one makes it so easy because I just spent money solving a problem with the video capture. And so I have a 4K HDMI video capture system over here that I just got configured and up and running with my digital microscope, which is on a tall boom, really tall boom. So I can either go in really close, snap stills, or I can do it from afar, which is probably how we're going to do it today. I'm going to treat it like another camera, and we'll see how well it does. Maybe it's not going to work too well. One of the things I do know about this microscope is that since it's on this long arm, it is a giant lever, and it tends to weeble wobble a lot. And when you're zoomed in on something and you have even a slight weeble wobble, it shows. So that's one of those, set it off at the side and forget it. Don't try adjusting it constantly, because when you do, it's all over the place. So anyway, this guy here, we're going to try it. I'm going to use my boom microscope, maybe swing that guy out of the way. So you won't have a view of my soldering station or anything. You'll just see me reaching over here to the guns, which all my soldering items are right here. They're placed at like a 45-degree angle so I can grab whichever one I need. This one I have to swing out of the way and probably block your view simply because it's blocking this guy. Hindsight's a 20/20, right? So I can use this guy right here, but I would like to do all my soldering stuff over the silicone mat. So, minor bug, it is what it is. I still like the placement of this guy because I can stow it right here above my monitor and it's out of the way. I know, guys, I seem to be babbling, but anyway, this is some of the hassles of setting up a system like this that, as far as I know, nobody has set up like this. It's a learning experience, Aaron, what's up, Mr. Aaron? I see your chat there. How you doing, man? Working housekeeping at Tribal Hospital. Oh, no kidding. Okay. Okay, so you're going to do a biomed internship starting in June. Ooh, exciting. Okay. Well, I'll tell you what, if you need some help finding a good position, let me know. I will gladly help you out. I do know some people over there in Arizona, and I haven't traveled up that way yet. Not yet. You are in Arizona, right? I'm curious where the tribal hospital is. Anyway, usually it's in the Southwest where there's a lot of those. Maybe I'm just assuming. You could be in Alaska for all I know. But nonetheless, welcome. 36 years. This is my just a week ago. I think a week ago. Yeah. Was my 20 years. And time flies, guys. Time flies. I know I look like I'm tired and everything. It's because, kids. But, I mean, time absolutely flies in this career field. And I can't say enough how much I love it. All right. Anyway, I have a bunch of components here. And the reason I have them here is because I did another video where I tore down a JBL boombox. And during that video, there's one tiny little chip right here at the tip of my finger that has got a hole in it. It's burned. And due to the cameras and the limited zoom that I had, I couldn't show people clear enough. Oklahoma, I was close. Okay. So anyway, I couldn't zoom in clear enough to show you guys. So now with the digital microscope, I can show exactly what's going on with this little bad boy. But then I had an issue with light. So look at this right here. I have a Welsh Allen patient light that I pulled out of the dumpster. I think it had a bad mount up there, and I fixed it. And now I have a Welsh Allen LED focusable light here on my benchtop, and it works well, especially with that microscope. So if you can imagine, I'm going to have a digital microscope, I'm going to have the Welsh-Allen light, and my binocular microscope for the detailed stuff. That's 3 dingle hoppers right here in front of my face while I'm trying to solder. I don't know how well it's going to work out, but you know, the devil's in the details. So I'll show you guys exactly what I'm talking about. So the Welsh-Allen is pretty good. I can focus the light pattern, which is really good, but when you're working with a microscope, you want as bright as possible. The cool thing is, with this long gooseneck, I can set it even at a distance, at an angle, and I can position my part like so. But you can also see what happens with this guy. It moves around, right? So let's go ahead and pull my digital microscope out. Now, one of the things I learned is with my more expensive video capture source, it doesn't always negotiate the EDID cable, the EDID table when I connect my microscope. The older one, the cheaper model, it does. Now that table, I explained in another video, is how any video source knows the details about another video source. So if you have like a video switcher, a video capture device or whatnot, you connect a camera or whatever to it, a TV, both those devices negotiate like what's your frame rate, what's your resolution, stuff like that. It even negotiates things like the model and whatnot. But so anyway, there's a negotiation that happens, and every single time my cheaper one would be connected, OBS just wouldn't work. I mean, it would have to be booted before I start OBS, because otherwise it just wouldn't work. The more expensive one obviously has some sort of non-volatile memory because it works. I just started my microscope right now out of nowhere, and I bet you it's going to work. Look at that. Wouldn't you guess it? So anyway, here is the chip that I'm talking about, and it would be that little bad boy right there. I know it looks blurry. We got some magic for that, right? Look at that. All right. How cool is this? And with this other gooseneck lamp, I could shine a light on the situation. That's not even the best part, y'all. Watch this. Digital zoom. What? How's that, guys? How do you feel about that? That chip is probably about 5 or 6 millimeters by 5 or 6 millimeters. It's tiny, definitely less than a centimeter. So it is absolutely tiny. And here I can blow it up full screen and show you guys exactly what's going on. So when I'm troubleshooting these electronics, I can show you guys the faulty components when I see them. And this light and everything is just fantastic. You can see it right there. So when you zoom in on a microscope, you have to have a lot of light. So there you go. That's all the way zoomed out. All right. So that's my digital microscope. And the goal, hopefully, is to use it kind of like this. So if I'm over here soldering, I'm hoping to not get it in the way of the light source. There we go. So I'm hoping to use it as a zoomable camera, just like that. All right. So when I'm working on something, I can show you guys right up close what's going on. And if I need to zoom, I still have digital zoom. How cool is that? Guys, I'm loving it. All right, so it's gonna work out better than I thought. All right, let's zoom all the way out. Switch my camera views up. Okay, let's go ahead and unwrap. Dog, seriously, seriously. Sorry, my English bulldog's right back there behind me, and she's, hey. You mind? Seriously? Jeez, can't get good help nowadays. Anyway, let's go ahead and take the wraps off of my boom microscope. Let's get it out of the way. We can go ahead and set up for this kit right here. I'll bring this microscope over when I get that one out of the way. And let's go ahead and do it. Let's pull everything out of the box. Let's see what we got. I'll go ahead and fire up my soldering station, which I love this soldering station. This is a really good one. Here, let's do this. Whoop. There we go. Come on, microscope. Let's do this. Okay, so this guy here just kind of lifts up. This guy here just lifts up. I love it. Because garages are not the cleanest place in the world, I'm always going to keep my microscope under drapes. There we go. All right. Excellent. That's a little creepy when that camera follows me around. All right, so this is my boom microscope. It comes all the way out. I can fit the camera on it, and maybe I would like to someday. The camera is like $400. And I did buy it, and then 5 minutes later I had buyer's remorse, and I'm like, what the hell am I doing? I just spent money getting this guy up and going. It's like, I need to be more resourceful. So I returned it, and here we are. It's gonna work though. All right, so what I was talking about is I can take this guy all the way over here. It does block your view of some of the stuff, but at the same time, I can still reach my stuff, sort of. Or maybe I can just take the head off. I don't know, we'll figure it out, all right? So let me bring my control panel over. So this is some of the stuff I'm still figuring out, y'all. Is like this Steam Deck control panel. I can control everything from this little doohickey right here, like my camera angles. And look at this. It's gonna be beautiful. Okay, let's go over to microscope, which is showing my mouse because it's a good mouse. And here's where it's gonna help me keep things in frame. I will use the Welsh Allen light to shine exactly where the microscope is. So when I'm soldering, I know exactly what the heck I'm doing. Okay, let's see. Let's do that right there. Sorry guys, we'll get it right. Okay, that kind of looks a little dim, huh? Interesting channel. Kerry Bryant, thank you very much, sir. That could be both a good thing and a bad thing. Always a good thing, I'm sure. Let's see. Have you ever been in patient care area? Aaron. Yeah, Aaron, have you? I'm sure he has because he says he's doing housekeeping. Am I using that new tracking? This is an Ozbot, which I have a love-hate relationship with. This guy right here. I can lock it down, or it can follow me, yeah, which does help. So between the wireless microphone, which is falling down, and that guy right there, this should be a more seamless experience, right? Let's see. Okay. So right now my microscope's kind of far. It doesn't need to be that far, right? Let's switch it over. So I'm trying to get you guys the best view of what I'm doing. So right there's the middle of my field of view. I'm going to move my light source. There we go. Sorry guys, focus is so detailed on these. How about that? Pretty good, huh? Okay. Anyway guys, let's go ahead and take a look in kit number 2. So in kit number 2, we have, first and foremost, is the brains of the deal, which is this guy. So mind you, this is an ECG reader. So I can literally hook this up to me and I can read the ECG. So this right here is a Nano. It's a system on a chip. It right now, I assume, is not programmed, which is going to be part of what we have to do. There's instructions in the box. You can see it right there. So next, I have a set of 3 lead ECG. And the 3 lead has got a 3.5 millimeter stereo jack. That's interesting. That is interesting, y'all. Okay, I've never seen a cable like that before. All right, I have ECG electrodes. Sorry, man, I'm trying to, this time I'm trying to pay more attention to the chats and stuff. So, sorry, guys. You know something? I heard about Lewis giving me a shout out, and all of a sudden, like, my viewer count just started going nuts, all right? And I was like, what is going on? And after I finished my live stream, I went over and I checked it out, and yeah, he gave me more credit than I am due. I'm pretty sure of it. So, Lewis is a good dude, man. He's definitely a pioneer. So anyway, guys, this is the parts kit. So here's the Nano. I have two 8-pin chips. Don't know what they are. I can research those. I assume that they're op amps or amplifiers, because what you're doing is you are taking a patient signal, which is a minute electrical signal, with these pickups. And when you take these little guys right here and you hook them up to you, there's different leads configurations. So you guys are going to hear leads 2, leads 3, leads 1. So there's different leads configurations, and those are where you place the electrodes. So there's only 3 leads. So one of them's going to go here, one of them's go down here, and one of them's going to go over here. Okay. So let's see if they're labeled. They're not labeled. Okay. So your different leads configurations take an electrical signal across different configurations of the heart. And the reason that you're going to do that is because it helps you diagnose between this muscle and this muscle, all right? Because there's different muscles that are part of your heart. You know, you have your atrials and your ventricles, and you know, so basically the most popular one that we measure is leads 2. So leads 2 is going to be right hand to left leg. So that's going to be from here to here. So you're taking the electrical signal across your right side of your heart, which is arguably one of the more important parts of your heart. Okay. Very cool to see this real time. You can explain things really well. Well, thank you. I'm gonna certainly try. So I'm sure if I mess things up, this is a live stream. There's no editing. We can't go back. All right. So things are so small. Give me a chicken heart any day. You know something? The chicken heart, by the way, guys, is a large patient simulator, and I had one here, but I don't have one here anymore. It's rather large, and it's got a bunch of ports on the outside. Imagine like S-video ports. And those S-video cables, or those DIN cables, that's the round style connector, there's various ones on the perimeter of this, and they'll handle things like invasive blood pressure. So you guys have all heard of non-invasive blood pressure, right? That's the cuff that you stick on your arm. So there's also invasive blood pressure, which they can take blood pressure from your neck, they can take it from your arm, they can take it from various sections of the body. And what that involves is actually sticking a needle down in and measuring the pressure from inside the body. There's some risks and hazards associated with that, which is why most people have non-invasive blood pressure, which is the pneumatic cuff, which maybe someday I will explain to you guys exactly what non-invasive blood pressure is. I think I did a video on it. Not really sure. God, guys, it's been 4.5 years, 700 videos, and I'm starting to lose track of what videos I've done and which ones I haven't. So anyway, if I go on a rant and I start explaining something, it's because there's a lot that goes into this kit that you all should probably know about. So let's see, I have a 3.5 millimeter jack. I've got various resistors here. This one here is what is that, 100 kilo ohm or 100 kilo ohm? Anyway, I'm pretty sure that's what it says. This one here says 10. I don't know if that's 10 ohm or 10 kilo ohm. Well, you know something? I do know, because there was a BOM, or bill of materials. Let's see, is that for this one? did I mess this up? I don't know if he included one of these instruction books for both the reader and the simulator. So these instructions here are for the simulator. All right. Either I lost a booklet or it didn't come with one because they have online instructions right here. All right. Online instructions are probably better anyway. All right. So anyway, here we go. We have 2 risers. We have 2 8-pin chip risers. So solderless. So all we gotta do is press the chips in. Very cool. And I have a USB. All right. Excellent. So I'm gonna take all the consumables and all the extra whatevers, and I'm gonna stick them back in here. Those do not matter at this time. The PCB is absolutely fantastic. Come on, camera. You know something? I'm not even gonna bother. You can see the silk screening is beautiful. It's pretty easy to read. 1 kilo ohm, 100K, RV1. There's my 2 chips. The silk screen is nice and clear. You can definitely see the orientation of the chips. My 2 risers are going to go here. Not bad. Curious about the test point. It's got TP1. Wonder if that's pre-amplified or post-amplified signal. Or maybe it's just power, like VCC. Don't know. But anyway, you see the through holes, the vias on this are beautiful. Whoever did this board did an amazing job. It's a really thick board too. Take a look at that. So, that's the board that we're working with. Let's get to it. All right. Let's see. Very nice kit. Yes, it is. I really appreciate that. So the Nano right here, I'm going to go ahead and stick this guy away so I don't damage it. Let's see. Oh, come on. My focus. All right. So anyway, this guy here, I'm going to stick it carefully off to the side because I will damage it. It's just the way it is. Let's see. Last month marked my 5th year. All right, 5 years. Heck yeah. So that means that 5 years, that means you're ready to go from Biomed 2 to Biomed 3, right? Pretty close. Or at least Biomed 2. Anyway, 2 chips. I'm going to set those off to the side. Do not need those. So what I like to start with are my larger components and work into the detailed components later. All right. So let's go ahead and stick all these resistors and everything over to the edge. I'm going to use my chip riser, both of those, and these 2 straight risers. And I'll also be attaching my 3.5 millimeter stereo jack. All right, here we go. Let's do it. Let's do it, guys. All right, soldering iron is on. It's on standby. My soldering iron is a Quick. I love this guy. It does a fantastic job. You know something? Let's see. Do I want to use this solder? Yeah, that's about right. I'll be working with some pretty fine detailed components. This one will probably work. I'll just go through a lot of it. That's all. All right, so let's go ahead. And last time I think I fed it off the spool, but this time I'm just going to clip a few runs because I'm definitely going to run through some solder. There we go. All right, that way there, I don't have that big old spool sitting there just bothering me. Okay, so let's go ahead and let's start with these chip risers. And those are going to sit very beautifully right here. Just make sure that little indentation in the chip riser, make sure that it matches up with your board, because that is going to detail where pin 1 is going to be. All right. So, right here's the odd part. is holding these guys and flipping the board. I do have various vices and stuff. Maybe I'll get around to using those. All right, hard to say at this moment. All right, I'm trying to get it in frame, guys. So if it looks like I don't know what I'm doing, it's because I don't. All right. Tell you what, these little chip protectors here are the perfect height. So I'm going to slide it right there. All right, there we go. Both of these guys are in. It's looking pretty good. Right there. All right, let's go ahead and tack down a couple of those guys and start this guy off. So first off, you can see my tip is nasty. It's like that on purpose because when we put away a soldering iron, we always tin the tip. Make sure that there's solder on the edge because it prevents oxidation as much as possible, really. So just remember when you're soldering that the soldering iron has got to get down to the socket. And when it gets down to the socket, you're heating up the socket, you're not heating up the solder, all right? There we go. And I'm going to do adjacent pins, so this corner over here as well. There we go. I know I'm going kind of fast, guys, because I've got this beautiful soldering iron now, which makes it so much easier. All right. I can almost, I have a large conical tip on here, or not conical, but a wedge. You see it right there. So one of the things I like about these tips is that the half oval shape, it tends to hold solder on that flat surface. You can see a flat surface right there on the bottom. So if I were to stick my soldering iron on here, you can see the bulge of solder that sticks on the tip. You can actually use that to your benefit when you are trying to conduct heat to a large thermal mass, like a ground plane or maybe a large component that is just sucking the heat away from your iron. You can put some solder on the end and help yourself out immensely. So you're going to see me reaching off camera quite a bit, and that's me going over and cleaning the tip, because once it starts to oxidize, the solder will not stick the same way and just creates drama and problems, and you know, you're probably going to get divorced, and you know how it is, right? So let's go. All right, man, it's so nice using this iron. I love this iron. So I can move it around quite freely now, because right now, all right, well, you can see the bend on my iron is going this way and it's upside down. So hold on, y'all. That's why I've got pliers and stuff sitting here, is because I don't like grabbing things that are hot with my bare hands. Sometimes this isn't a good idea to move while it's hot, because you'll start getting thermal errors because it's measuring the temperature inside the tip. This type of soldering iron here is one of the best that you can get, because it uses these all integrated tips. You can see right here is a conical tip, and the thermistor is inside it, the heating element is inside it, and it's all one unit. So if I want to change it on my iron, I just grab onto it with a set of pliers and I yank it and I stick this one in, and this one starts heating up immediately. That's the beauty of this guy, is you don't have to unscrew things and take things apart in order to change heads or whatnot. You can just simply grab onto it with a set of pliers like I have here and go to town. All right, let's get these other ones back here on the top side. Tell you what, I'm almost second guessing why I didn't put this in a clamp. I have like 5 or 6 different types of vices underneath the table here for holding circuit boards and stuff. And I said, nah, I don't need those. Just a little baby board. What do I need something like that for? Come on. What is going on with that particular one? Okay. So as I was heating that up, you can see right there, see that pin? The solder kept going and disappearing on the underside. Now it's starting to get upset There it is. It's a good thing I didn't go any further because it was creating a solder bulge. Now what you can do to straighten that out, it's going to require some heat, and the solder was seeping in with gravity, and if your through hole vias are too large, it will also encourage the solder to seep all the way through. So what I'm going to do is invert the board like this, and I can heat it up either like this from the top or from the bottom, and that solder will suck back through to the backside and create a nice neat little cone like it's supposed to. So it's going to require a little bit of heat. There it is. Let's get the one next to it too. Perfect. Beautiful. So if you guys see the off color here on my board, that is just flux, all right? Y'all that haven't done too much soldering, don't worry about it. It's okay. I'm not burning the PCB, not yet anyway. So far, this board is very resilient. I mean, my iron is sitting at 320 degrees C, so I do like using a warmer iron, but it seems to be taking it just fine. Just fine. Here, I'm gonna go ahead and straighten up one more of these from the bottom. There we go. Nice. Beautiful. So I like it when each of my pins looks beautiful. You can see right there. This soldering iron right here is an absolute pleasure. All right, here we go. Those two are in. Let's go ahead and put a larger component in, like the 3.5 millimeter jack. All right, for this one here, I'm going to stabilize it with my pliers to make sure that those components are as flat as possible. Again, I could have done this with, I could have so easily done this with the vise. There we go. Beautiful. So that tacked it down. Now I can just go to town on it. One of the things I'm most fussy about is to make sure that the components are sitting flat to the surface. So if it's rocked up or anything, you can see right there, oh, here's the side profile, sitting nice and flat, beautiful, the way it's supposed to be. Right. So since there's a lot of plastic or composite on this jack, you don't want to put too much heat on it. Just get in there, get her done, and get out of there, right? Don't put too much heat on it. And all these pins, they look beautiful. You can kind of see it from that profile right there. So what you really want to see, oh, hold on. Right there. There you go. You couldn't really see it from far off. So what you want to see is a little cone that's evenly spaced all around those pins, like so. All right. So even though from a distance it doesn't look like it's all right, it's all right. So some of these almost got a little too fat, but it's okay. Those ones are bonded all the way around. I can see them pretty cleanly. You can see the cones on those ones. Beautiful. Excellent, moving right along. Now some of the most difficult components out of this entire kit is going to be the straight risers, and the reason being is because you want to make sure that they stay linear to one another, because otherwise you're bending the legs of the chip when you seat it, all right? So these guys here, there's two ways of doing it. One way is I could seat the chip right now. Last time I actually lined them up before I did anything else. This time here, I'm going to show you guys the method of doing it by using the chip. I'm not going to put so much heat on it that it's going to affect this, all right? If I were to solder this guy here directly to the board, it would be putting a lot of heat directly into this PCB right here, which would be a big no-go since it's a computer, right? There's a orientation indicator right here. It says USB, so it wants my pin 1 to be right over here. So the good thing about this right here is that it's going to keep both of these risers perfectly parallel with one another as I solder them down. The other one, I just made sure that they were straight as possible, and then I soldered it. I think I like this way better. And because of the tension, you can see that it's sticking in there, right? Very cool. Maybe I'll do it this way from now on. So just the same, I'm going to tack it down from 2 different angles. Oh, there we go. So I'm going to tack it from this corner and then this corner over here. There's 1. There's 2. And some of you guys that are probably wondering, why am I not coating it with a lot of flux like Lewis does? That's because this is a brand new PCB. Every component here is clean. One of the problems is that things oxidize, especially over time, especially when you put power through them. And that's when you have to use a lot of flux. So if you're doing rework, yes, you have to use flux. If you're doing one of these solder kits, no flux, all right? So you can see right there, the pins that I did. Man, I think I'm gonna love this digital zoom feature. All right, so you can see these pins, the middle pins I did, and then the end pins. There you go. So now, just go ahead and leave it at that angle right there. Come on, zoom out, there we go. So leave it at this angle right here. It's a perfect angle for me to operate at since it's kind of slanted. And I can just tack the rest of them down nice and easy. Let's see, I'm not following through with the comments. Sorry, guys. Can anyone buy these kits? Yes, you can. Absolutely. So, guys, these kits here were supplied to me by HTM Workshop. It is htm-workshop.com. All right. So it gets you in the door and you start working with technically real medical equipment, although it's not patient safe, but I mean, an ECG reader and an ECG simulator. We use ECG simulators all the time to test the equipment. So that's basically what you're doing. And inexpensively, I might add. Very inexpensively. All right. I'm a senior specialist. I was supervisor, then manager, left my hospital, went somewhere. It's been 3 years now. Want to get back and be a tech again and coast to retirement. Well, Carrie, I can certainly help you with that, man. You let me know what city and state you want to work in. I'll make it happen. I know people in every state. How about printing a fixture plate for all the parts you slide under to hold in place? Now, you could do that. You could definitely do that. Catherine, where have you been, man? Aaron McLean, I'm just used to holding my fixture, my bad. I have, hold on, boop. When I said I have a whole bunch of clamps, I have a whole bunch of clamps. I have this little guy right here. This one's pretty good. Actually, probably about the right size for that. There's grooves already cut into the deck for holding things at an angle, or you can see grooves cut sideways for holding the PCB flat. That's a good little vise. I have some classics like this one right here. It's a General. It's based off of the Panavice, which I have some Panavices. How about this big batter? This big baddie right here. Yeah, so if I wanted to do more circuit boards, hell, even this one I could have done, but this is a little cumbersome, I think. For working for small stuff. And then I have this painted guy, this painted fellow right here. This is certainly an old one. It's a Panavice, probably one of the first versions. Also one of my favorite, this little crankety crank. And I like that it's got these two flat spaces right here. So there's rubber guards, but there's a flat space. That flat space is perfect for jobs like this one right here, because you put your PCB on top of the rubber, clamp it down, and it holds it. Kind of like parallels do. If you guys have ever seen somebody do machining, they have something called parallels, which are machined flat metal blocks. You stick it in your vise, and then you stick your workpiece on top of it, and then you clamp it down, and that makes sure that both sides of your workpiece are perfectly parallel. That's why they're called parallels. So I have those vices and clamps. I also have some trusties, like the quad hands here. These are magnetic. Love them. You know, believe it or not, I've been doing so much of this for so long that I prefer to just kind of hold wires and stuff together with my fingers while I'm soldering them, because I think I can go faster. By the time you set up these jigs and everything, I'm pretty sure I could probably be done. And maybe with better work quality, because I can position them while the solder's hot, versus these ones, it's a little more difficult to position while it's hot, all right? Let's see. I know I have more vices than those. Well, for one, I like rum. I mean, wine, woman, and song, right, guys? I've got my vices. I think I have some boxes back there, and those boxes they also have some soldering vices in them. You know, you see them at yard sales or something, and I just pick them up, you know. You never know, and you can tell they're all different configurations and whatnot, and you never know when you could use them. So Aaron McLean has to go back to work. Aaron, get back to work, man. I use small vice grips to gently hold my boards. That is also an idea. I've used vice grips myself as well. They work good. They do. Interesting. Watching a diamond painting stream. Okay, that's interesting. I didn't know about that. A Dremel vise. Yes, I've used those as well. They're not as heavy duty as some of these, but you don't need it to be, right? You're not going to beat the heck out of it. I have that Hacko that looks like an extra thick metal hockey puck there. You're talking about this guy over here? That one? Those guys are pretty nice, man. They are. Quite the collection. Well, thank you. Like I said, you never know when you could use them. I also have some magnetic vices. So I have other fixtures and whatnot, like this guy here. So if I'm working with metal or something, you know, I have other things. Just, you know, it's the thing about being a person that fixes things. We collect tools and stuff, especially if you actively fix things, because you never know when you're going to need them. And I do often need them. That blue container back there is full of fasteners. Full of fasteners. If I said I wanted an M4 by 0.7 fastener, I could probably find half a dozen of that size. And when you know it, that's a pretty popular size for medical equipment, amongst other things. But you know, I can find all sorts of fasteners and stuff, just the same as tools. Fasteners, you can't do work without them, right? Anyway, let's get back into this. So I got my circuit board here. I have, I don't know, let's just run through them. I think I only have 6 or 7 of the pins done, and you'd be surprised how fast you can get this done. So you just want to get a lot of you want to get a lot of heat down there on the socket. Oh, there we go. And you can see how I'm holding the board and positioning the board while I'm just running the iron, and I can actually do it kind of quickly. And I'm using a rather thin, you can see that solder there bulged up. When you see it bulge up like that and it starts getting round, clean your iron, come back and touch it again and suck some of that solder up, because that would be a cold solder joint or too much solder. One or the other. There we go. can see my piece of solder here is getting pretty short. If you don't heat up the socket enough, you'll know, because the solder will stick to the pin and it just won't adhere to the socket. You need heat. Get that heat down there nice and low. These are really resilient boards. They're not even discoloring. I mean, this iron is running hot. It's not even discoloring. Of course, it's white, but it's got some sort of coating on there. I dig it. All right, so I just redid that pin because why not? Oh, sorry, am I out of the camera frame? I wish you guys could like yell at me across the stream. Maybe that's why I should live stream with like Zoom, because then you guys could just yell at me like, "Hey, Justin, you're out of frame," and I could just pull it back in. Come on. You can see I'm sticking my iron kind of off to the side so that I'm heating up the socket, and what I'm doing is I'm touching the tip of the iron with the solder. That melts a little bit and it conducts heat to the pin really quickly. And by doing that, I can get a really good connection quickly. There we go. All right. So the cool thing about having a microscope is to go ahead and inspect these with detail. There's one pin that I think is a problem. Let's see if you can spot it. See, clean, 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 clean. Look at this guy right down here. See that guy right there? You can see how it's kind of bulged up. So if I was soldering under the microscope, my binocular microscope, wouldn't have been an issue. So what you do is you clean your iron off like I have here, and you're going to see I'm going to touch it. I'm going to suck some of that solder off. Whoop. There you go. Now you can see those pins are clean. Let's see, I got one more right here that looks a little ugly. Bam. See that? Beauty. So if you ever have a pin that doesn't look right, just clean your iron and touch the iron to it and remelt that solder, reflow it. Beautiful. This one right here is a little questioning, isn't it? That one right there. From the visible eye, you can't really see it, but I don't think there's enough solder on that bad boy. Okay, so I have to see it, guys. It's gonna be that pin right there. Oh, shoot. I didn't get it in frame. Let's see. Now those all look good. See if I can show you guys on another one. Sorry guys, those all look good. Anyway, let's clean the iron, stick it away. Let's press on to the next thing, So, okay, what I like to start with next is going to be the things I have a lot of. So, I have a lot of, what are these? 1K? Okay. Let's zoom back out, y'all. I was watching. I wish I could highlight where I left off reading the comments so it's quick and easy to get back. I have not looked up the price of those kits yet, but I'll tell you what, they look really good, and I'm thinking about buying more for my technicians that are on my team, because I believe that soldering is an essential core skill for biomeds. Even though a lot of biomeds say they don't do it anymore, when you need to, it's best to have that skill in your toolbox for the day you need it. TTS chat can be fun as long as the chat is tame. Yeah, this one's tame. I like this one. What's the benefit potential issue with the bulging solder? I'm new to electronics and I usually deal with mechanical systems. Yeah, too much solder means that it didn't flow right usually. Knops is absolutely correct. So that is exactly what it is. It's a potential for a cold solder joint. So what we want to do is we want to check that and remove the excess solder and reflow it regardless, right? Cold solder joints create intermittent issues. And there is nothing worse in electronics, and especially in biomed, than intermittent issues. You know, as these components heat up, you'll get connectivity, and as they cool off, they will shrink, right? And if you don't have a real good connection between two surfaces like the pin and the via, which is the through hole, then that bulge of solder will actually create like a ring at its base, which is where it technically detaches. If it didn't flow correctly, if there's a thin portion there, the weakest link will break. So as it heats up and as it cools off, which even marginal, there's going to be thermal expansion, what it's going to do is it's going to create a break. So it's one of those quality control things that we all do, and it's nice having a microscope for that exact purpose. If you see bulging solder on the pin, then it means it needs to be reflowed. So clean your iron, go back, retouch it, try again, all right? Price for the kit 79 down from 109. Interesting. Interesting. Well, he sent this. I mean, honestly, because you have two of the nanos on there. I mean, the nano is it's a full-on computer, all right? And you have to remember, like, making these PCBs and stuff, this is not cheap. Here's the best part of buying these kits, though. The money that comes from these kits and whatnot is going back into HTM education. Go to YouTube and check out HTM Workshop. He has a YouTube channel, and it's better than mine. And I'm not even embarrassed to say that. It's better than my channel. He explains things better. He doesn't have the production schedule that I do, but he explains things far better than I do when it comes to theory. His editing is far better than mine, and he's an overall good dude who's got a real solid mission. So all the money that comes from this as a profit goes right back into HTM education to help out with kids, you know, kids or young people, to get them into this career field. All right. Boop. Let's go ahead and do that. We got those 1000K ohms. So what I do is I bend my legs like so, immediately off the tear, and I thread them through like so. And then when I get them down like this, you see how there's a little bit of a bulge and it doesn't want to seat flat? What I'll do is I'll grab the leads and I'll kind of roll it over my finger and pull it so it's tight. Just like that. You want your components to look nice and neat by sitting as flat as possible, like so. Once you get it flat, I bend the legs sideways, like so. And that way there, I can solder them down and we're good to go. So here's the next one. It's obviously going to work a little bit easier if you bend the legs as close to the component as possible. Resistors are bidirectional, so it doesn't matter what direction they are sitting. Capacitors are not necessarily that. If you have electrolytics, which this kit does not have, they are polarity sensitive. So you have to be mindful of that. Come on. There you go. There you go. Do it. Got two more of these. Oh. I wish I could zoom out a little bit more. Here, how about this? There. I want to get you guys the best camera angle without it being like right here and all you see is like my fingertips. I mean, as scarred up as my fingers are, you know, my hands are just full of scars and stuff. So, but just get you a better view. let's see, 1K. All right. You're going to see that this board's going to get a little busy. So if it gets a little too busy with the legs sticking through, then solder them up. Use your flush cutters. These flush cutters are cheap, rather inexpensive. I've seen a new set of flush cutters that I want to buy, made by, who made those? I think it was Nipex. But anyway, this is the set that I currently have, Tech Cut. They were good. You can get them on Amazon. Let's see, I have one more, 1000K. Here we go. And where is the last one? So you have a 100K, I have a 100K. I have a capacitor, 22K, 10 kilo. I have a 100K. Oh, right here. Jeez. You guys are probably screaming at me. It's right there. Okay. And pull this guy tight. All right. Here we go. And that is a pokey mess right there. All right. Let's get it. Now, you have to be mindful, these legs are going to soak up a little bit more heat. So you might have to apply heat a little bit longer to get it to really flow. Gosh darn it. Okay. Here we go. Here we go. Come on. I'm doing this upside down and backwards. Okay, okay. This one right here had a little bit extra solder, or it didn't flow right because the solder bulge is sticking up the wire. Here, I don't know if I can show you too well. Let me see if I can zoom in. Show you some of the stuff I'm looking for. So let's see what I'm talking about. So you can see this right here. See that? So what I'm going to do is I'm going to touch it with my iron. Whoop. Touch the socket, and you'll see that it will flow down into the via. Oop, there we go. I want to make sure that I got good contact in that via. Here we go. Okay, the rest of them are looking pretty clean. Then you're going to take your flush cutters, these guys right here, and you're going to stick them right there near the base, clip them off. Probably should be wearing eye protection right about now. I'm going to do the safety squint, they say, where you just squint your eyes when you get ready to cut. Okay. All right, so I got a few more to go. Man, I'm so glad that this is the first time I've had real good camera angles when I'm soldering. People always ask, hey, can we see what you're doing up close? So see how my iron, I'm sticking it off to the side. I'm heating up the socket. I'm going to touch the edge of the iron right there. Just boop. Just touch it like that. And it's going to flow that joint really quickly. So same thing, heat up that socket. Boop. Just like that. Okay. Next. So you can see I've got some stuff on my iron. Let's go ahead and clean that iron. There we go. Didn't think that one was flowing, but with the camera angle and with my viewing angle, the reflection was actually keeping me from seeing the solder when it was liquid. Perfect. All right, y'all. This is looking real good. Okay. So I'm going to have to, in another video, I'm going to have to hook these guys up to the computer, program them, and then go through and do some stuff with them, see what they can do. But this is not going to be that video for sure. It'll be like middle of the night. This is like watching surgery being done. You know how many cool surgeries you can see on YouTube? You can watch like, let's say arthroscopy of a knee, or you want to see spine surgery or even brain surgery. You can see it on YouTube. How cool is that? This is like what I have Knipex end cutters that are pretty good. Huh. Yeah, I'm gonna have to check those out. All right, what's next? What's next? Let's clean up our work area a little bit. I have a, what is that? A 22? Is that a 22K? Yep, right here. It's right there, 22K. No kidding. He's got it written on there, so tiny. You see that? All right, let's do it. All right. You can see how I'm pulling these resistors down. Now the other thing you can do is, if you have a set of these miniature needle nose, just grab it, just kind of roll it a little bit like that, pulls them right down. But you have to be careful when you're using hand tools, because you could potentially pull the wire too tight. You know, you could damage the resistor. So let's see, that's the 22K. There's only one of those. I would love to see the circuit theory, like why the board was designed the way it is. See, I'm more curious about the how and the why. Let's see, that's good. That's good. Okay. All right. Here we go. Next, let's go with 100K ohm. All right, I got 3 of them. So those of you who are not really into electronics, the reason we know what a resistor is because of the color bands that are on them. And I could tell you the theory and, you know, what's going on with the color bands, or you could just use what is that, Google Lens, and just take a picture of the resistor, and it will show you what the value of the resistor is. It's crazy. So there are like resistor calculators out there and stuff where you have drop down menus and you put in the color of your bands, and it will tell you what value it is. Now the last ring, which on these ones is gold, the last ring tells you the accuracy of the resistor, 5%, 1%, 0.5%, whatever. So there is that. Let's see, so I have 3 100Ks. There's one. Okay. There's 2. Now it looks like these 3 100Ks are, these ones here are right there. There's 3 different channels coming in on the 3.5 millimeter jack. So I'm kind of curious what their function is, if there's some sort of isolation between the circuitry and this guy, you know, because it's going to attenuate this signal right here a little bit more, or are they filters? So this one, and this guy right up here. They're acting as some sort of filter at 100K. And then whatever that signal is after those resistors, that is going to get amplified and analyzed by the little nano. Come on. There it goes. Here's my 3 100Ks. Let's do it. Oop. I kind of did that on purpose. That's right, we'll fix it. We'll show you guys reflowing a solder joint here. Now, one of the things that will definitely aid in flowing of solder is flux. So if your solder is old, or if it's not the correct diameter and you don't have enough flux, because flux is in the middle of the solder wire on most solders, and if you don't have enough flux in your wire, which you can see all the yellow on my board, so there's definitely a lot in this. If I'm using the wrong diameter wire, there's not going to be enough flux in the wire for some certain solder joints, and it won't flow correctly. Anyway, let's see, right here, you can see this little guy right there is the solder bead is actually sitting up the wire. You can see it right there, much better. So I'm going to come through from the bottom. My soldering iron I just cleaned. So what I'm going to do is come in and reflow it. There it is. There it is. And you can see that little smudge right there that's coming up the wire. That's okay. That's all going to get trimmed with my flush cutters anyway. So let's see, did I get all those? Got it, got it, got it. Perfect. Okay guys, we are almost done. We're doing good. There's one. Come on. There's two. Three. There we go. Nice. So you're going to see me, I keep cleaning my work surface because there's nothing worse than when these little bits of steel stick you in the arm. So that's why I keep cleaning it off and moving them over. All right. Let's see, what else I have? One more resistor, and this guy here is a 10K. Let's bend this guy down. So 10 kilo ohm is going to be this guy right over here. Perfect. Yes. Come on. Excellent. Perfect. All right, nice and clean. I'm looking for any of these cuts from the trim cutters to be nice and sharp, because if they're sharp, then I'm going to have to trim them again or file them down. That's nice and smooth. Good. Let's see. Sorry guys. PCB layout design is super interesting. I like watching people work their designs. You know something? You're absolutely right. There's such cool ones that you can do, and you can get entire solder boards. And if you do CNC like I used to do, you can actually use those programs to cut your traces and stuff in the board, and then you can go ahead and do your mask, which is the overlay. And I mean, there's such cool stuff on YouTube. I'm such a nerd for this, and I'm so happy that so are you. So are you. Does it matter which order you put them on? No, it does not. It does not. It's doesn't matter at all. I'm just a little curious by something, by the way, guys. I still have this RV1. RV1. What the heck is RV1? I haven't figured that out. Okay. Let's put these caps down. I don't think I'm missing a part, but I guess we'll find out in a minute, eh? Okay, those caps are super easy. All right, these are the last two solder-in components. Come on, there we go. Excellent. Okay, let's clip. Okay, flush, everything's good. So next we have our chips. And here's the thing, these chips are not the same, are they? Those are not the same. Nice. Okay, so devil's in the details, right? So there is, in the silk screening, there is a tiny little part number right there. So let's go ahead and let's take a look and see, what do they say we need? Come on down. Okay, so one is AD623. Let's see. So this is a TLC. Okay, so this chip here goes here in this spot. That means that this one here is, yep, the AD623. It's right there at the top. Tough to see, but it's there. All right, hold on. I'll get you there, guys. So you should see what numbers I'm looking at so that you know how to identify chips. Okay. See right there? It says AD623. AD623. See the indent in the chip? See the indent in the chip? That tells you where pin 1 is, alright? So sometimes these chips are a little too wide, so you have to like flex them to get the pins all lined up. This is what I'm doing right here. You can see one side the legs don't want to stick in. They're a little too stiff. So what I'm going to do is I'm going to take the chip and I'm going to stick it on its side, and I'm just going to kind of roll it a little bit like that. There we go. So all I'm doing is rolling them just a couple degrees to get the legs a little bit closer together. Okay. And then it should line up. Like that. So check it before you press in, because you do not want one of your legs to bend. That would be not good. So once you verified that it's all up, correct orientation, just press it in and it's in socket all the way down. Cool. Next chip. So you can see configuration of these legs. They're way too wide, just like the last one. So this side right here looks like it's bent out a little bit, so I'm sticking that side. Just kind of roll it a little bit. Bends all the legs uniformly the same distance. Okay. Here we go. So on this chip here, notice how it doesn't have the indent like the other chip. This indent right here, that signifies that pin 1, which is also normally indicated by a square leg. Yep, right there. So these through vias, shoot, come on. Hold on, guys. I'm doing too much stuff. So what I want you guys to pay attention to is this through via right here is square, whereas these ones you can see they're round, round, round. This one here, the solder pocket, is square. That's because this is leg 1. So normally the indent tells you that leg 1 is down at this end. The square pocket right here, in case there is no silk screening like this one here that shows you the little indent, if you see a square while the other ones are round, that's telling you, hey, this right here is leg 1. And if you have any doubts, what you should do is pull up the data sheet on AD623 and see what the heck that chip is and what it does. The data sheet will also tell you what pin 1 is, and it will tell you the pinout for the entire thing. Hold on, guys. My mouse is over here. It's tracking. Unless it's the way here, so that's true. There's one with 3 holes. Looks like potentiometer. Might be camouflage on your mat because it's blue. I'm not. Yeah, it's true. It might be, but I'm not seeing it here. Although that's why you never throw away your boxes until the very end. All right, so that you can check every single bag to make sure you're square. Anyway, let's see. Hold on, guys. Let's do over table screen share. All right, excellent. Boop. And this one here is AD623. Data sheet. So normally you type in data sheet as well, all right? So you can see that one chip, the AD623, it's an $8 chip, that one chip. So when you're like, man, this whole kit's $90, that one chip is $8. You see that? Anyway, the AD623 data sheet, let's bring it up. Sure. Anyway, I guess this is a data sheet. Not a typical engineering data sheet. There we go. That's what I was looking for. Okay, so data sheets are your absolute friend in electronics, okay? So you can see the chip number right here. It's a hyperlink. Good, guys. I love that. Tells you the voltage range, tells you everything about this chip, like its function and whatnot. And then it shows you a pinout right here. So there's different configurations of this chip. Very cool. So this chip, let's see, what is it? It's an integrated single or dual supply instrumentation amplifier that delivers rail-to-rail output swing using supply voltages. The AD623 offers user flexibility, allowing single gain set resistor programming. Okay, so we program it with resistors, which is, earlier I said I don't understand why some of these resistors are the particular values they are. That is why. Because we are setting the value of the gain of this amplifier with the resistors. Okay, makes sense. So here is what's going on inside that little 8-pin chip. You can see the leg numbers right here, 2, 3, 5, 6. Let's see, there's pin 4, pin 7. Interesting. All right, and let's see. There you go. Okay, here's the other part of the data sheet. It tells you the resistors and the values if you use particular resistors in your circuit. And then they usually at the very end of data sheets, they give you an example circuit of how it's used. Right here you can see the pinout. Right here's pin 1, which is RG. Down here's a little table. RG, pin 1 is inverting terminal of external gain sensing resistor. I know that sounds like a lot of mumbo jumbo, guys, but it really is not that typical. So basically, instead of using a potentiometer on this board, so the RV is a variable resistor. And I don't have a variable resistor because I think we are setting it with resistors, and I just seen a problem with my board. I'll show you guys the problem in just a moment. Anyway, I think maybe that RV1 was if we wanted adjustable gain, and maybe he opted out of that. But anyway, this is the pinout, the look of the chip. So this pin 1 right here, the RG, the gain resistor, would be that pin 1, which was square, while all the other holes were round. So gives you charts on the performance of the chip. Now if you're designing a circuit with this chip, you're definitely going to want to take a look at these charts, because there's a lot of information in here that's going to tell you about what other components you can mate up with this chip to make it function correctly and not affect other chips, other components. So a lot of charts. Man, there's more charts in this than I've seen. So anyway, here at the very end, you can see that they're giving you a little example of how you can use it. Applications right here. And a little circuit diagram of different ways that you can use it. See that? That's the cool thing about data sheets, is you can see how people would use it. So here's the chip, the 8623, and you can see analog power supply, digital power supply, yada yada yada, a microprocessor, and I don't know what else to say about that. I mean, it just is what it is. There's several different examples. This is actually a really good data sheet. Some of them only show like one example. This one has a bunch of different examples. But anyway, guys, that would be data sheets. All right. Thought it was pertinent to show you guys that in case you're questioning, like, how do you know what's this or that? Data sheet. All right. You can look up any semiconductor, unless it's proprietary, and find its information. So anyway, let's get back to this one. This lowly little chip right here has a dot. You see that dot? That dot indicates pin 1. You see that? That will also be in the data sheet. It will show you a dot on the little picture that's in your data sheet. That shows you pin 1, all right? Pin 1 is always going to be down here. Again, I told you it's going to be the square socket. So it's going to be down towards the cove, which is already there. Okay, so I'm going to set these legs. There we go. Check one side, check the other side. Make sure that both those legs are in before I press it. Looks good. Press it. Cool. So there we go. So look at this guy right here. I don't know what happened there. He started falling out. I don't know. Started having second thoughts. No idea. But I got to fix him. All right. I could leave it. Could leave it. But that is not what we do, right? So you can see all the others are profiled perfectly. They're beautiful. And then what happened there, right? So what I'm going to do is I'm going to put pressure on the top. I'm going to heat up the socket from the bottom, and it's going to slip into the pocket. So you don't want to put too much force on it, because if you start forcing it, it could rip out this via, which is that little hole right there. It could rip out the conductive material in there. So you want to make sure it's really liquid before you put a pressure on it. There we go. Oh, and of course you guys knew that was going to happen. That little resistor got hot in a second. I have done this many times before, so don't worry about me, y'all. There we go. So you can see I pushed it through. Now I'm going to heat up the other side, push it. There we go, just like that. Heat up the first side. Just kind of go back and forth until that guy is seated all the way down. And you know, he's melting into this foam I was using. There we are. There we go. And that is almost as good as it's going to get. Let's see, how else could I do this? I'm going to put light pressure with these pliers. Come on. You can hear the board squeak as it realigns itself. That's all good. And it might not be perfectly centered, but it's down. All right, cool. Now what I'm going to do is I'm going to reflow these, because when you heat up solder like that without flux, it tends to oxidize and create a bunch of problems. So I'm going to reflow them like that. Right there. There we go. Reflowed. Reflowed. Let's clean it up. There we go. Perfect. Now I can reclip. All right. Close. Yeah, it's lifted a little bit, but not much. It's off to the side. I'm okay with that. All right, guys. So this board is technically done. I'm going to let's go ahead and check the box just to be sure that there is no variable resistor in here. Don't throw away your boxes, y'all. Don't throw away your boxes. Look what I found. You're right. You were right. There's a little potentiometer. Let's go ahead and get this guy in. Okay. Sometimes with boards there are revisions and they will go without. But on this guy, which is not in frame, there we go. This guy, they of course are going to use every component. Tell you what, I don't like doing that. What I'm going to do is straighten out some of these legs. Puts a lot less stress on it. There we go. I straighten out the legs, and it'll slide right in. And I wonder if this is something that we have to calibrate on first use. See, when you straighten out the legs, no problem, right? There we go. And it does still stay in. So let's go ahead and tack that guy down. This is the last component, and this board is done, guys. Okay, my soldering iron tip is definitely dirty. So there's a little more thermal mass on these legs. Check it. Beauty. Okay guys, let's go ahead and do one final check. Let's make sure that this board is good before we sign off and say that it is done. Those are looking pretty darned good. Now, all the flux that you guys are seeing, we clean that off with rubbing alcohol and it will be beautiful. Okay. Looks pretty good. Let's go ahead and raise this guy up. And let's go ahead and clean this guy. All right, guys, I am using HEB 99% isopropyl. And let's see, let me get a softer bristled brush. All right, some of you guys might have recognized that guy right there, all right? So 99% isopropyl, excellent thing about it, you can see all I did is I put one tiny hole in the cap. 99% isopropyl almost completely evaporates and leaves little to no residue whatsoever. So it is what I only recommend for electronics, because last thing you want is some residue or even water, because, you know, stuff happens. I'm trying to level out the board here if you guys are wondering what the heck is that dude doing. So what I'm going to do is I'm going to soak it and then give it a little scrub, all right? Let's clean up some of that flux that's floating around that board. So you guys can see what I'm doing. I do have an acid brush here, right? Ah, yes I do. Yes. Okay, acid brush, like this guy right here, are fantastic for this purpose because they hold the alcohol in the bristles. And holding the alcohol in the bristles works so much better to get the solvent up there. See, this board is so beautiful when it's done. It's a white PCB. You clean up all that flux. I'm going to give it another soak. All right, there we go. Cha, 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 cha. And yes, this guy does have alcohol all over it, right? But there's a secret. Either I could leave it to air dry, or I can go to my quick hot air station over here, which is not even plugged in yet, because why would it be? Come here, you. There we go. At this point, I'm going to shut my soldering station off. Use my hot air station. I'm going to set it on the lowest temperature, which I think is 200. Yep, there it is. You can see my lights flicker because like my electrical system is not going to be possessed because of how this heating element works. Here we go. Okay. And the beauty of this hot air station is that it dries everything like instantly. See that? Including my silicone mat, which is soaked in alcohol. I'm not too concerned with that. There we go. So you notice I'm moving it around steadily, not leaving it in one spot. Just heating the board up to 100 plus degrees, this alcohol is going to evaporate really quickly regardless. So you don't have to like sit there and cook it. Excellent. And then the cool thing about this station here is when I put it on its dock, it goes into cool down. I love it. Love it. All my old soldering stations never did that. Let's go ahead and shut this guy off. Boop. Come on, power. All right. Beautiful. Well, I guess also remember to put the cap on this guy, right? So that is it. That is the kit. So the next step would be to program it. And then when you are done, that's when you're going to have this guy, which this guy, it feels like there's silicone wires. Those feel like they're pretty good wires. So anyway, this guy is going to plug in here when it's programmed, and these guys will go in your 3 leads configuration across the body, and it will pick up your signal. Now what it does with it from there, I don't know, but we're going to figure that out together. That's going to be my next video in this series. Now that I have both the boards put together, they are beautiful, by the way. These boards are absolutely beautiful. Take a look at this. So here's the simulator. Nice and neat. The configuration is beautiful. You know, nice dark PCB on this guy. This guy here's got a nice white PCB. What I'll probably do even though it's kind of a dead giveaway, is I will probably write on the back like simulator and reader, you know. So, oh, it already is. Check that out. Okay. This one right here, come on. It says ECG Sim. See it in the dark? It's cool. I don't have to write anything. I didn't know that that was silkscreen on there. I should have known better. Mr. Brian Bell, he's already on top of it, man. That dude knows exactly what's going on. So, cool. That's it. There. Other than that one resistor that went a little wonky, the entire setup here was beautiful. So next video is programming and exploring to see what the heck can we do with this cool tech. Very cool tech. Anyway, guys, how cool is that? Can I get ethanol in Colombia? Catherine, I didn't know that you were in Colombia. You nut. That's awesome. Could you ultrasonic? I could ultrasonic, but I like alcohol. Who never burned their finger like that? Yeah, I mean, we're all gonna do it. And just being honest, like the ends of my thumb, my one thumb, I cut the end of my thumb off on a bandsaw. And I know you can't see it really because it kind of grew back, but there's no nerve endings and it's really thick. So if I usually do things like hot, I'll usually use this hand because it's got like a callus at the end. But anyway, that's just me. That's how I do it. I can only get ethanol in Colombia. You can't get isopropyl alcohol? Really? Isopropyl alcohol is everywhere here. It's like this container here, like electronics grade alcohol. If you were to go to an electronics store, it could be like $10, which is reckless. This cost me $2.50 at HEB. HEB is the local large grocery store here in Texas, and it's fantastic. We love our HEB. You could have a drink too. Mr. James, how dare you? You're damn right. Yes, Mr. Knops, acid brush, they work quite well. You just got to make sure that you dry them out. And one of the cool things about the acid brush, they are disposable. You buy them like a pack of 10 for one, but for two, the metal case, I have magnetic trays up here, and those magnetic trays hold all my tools, and it's steel, so it's nice and easy to go ahead and put up there. See? It's magnetic. Come back to me. Anyway, guys, that was fun. That was really fun. And I'm happy that you guys were here to see it happen. Anything could happen, you know? It could have went really wrong, but it didn't. I'm happy about that. So, like I said, next video, I don't know when it's going to be. Could be soon. But tomorrow, no, shoot. It's not going to be tomorrow. Wednesday, I'm going to be on the road, and I'm going to be visiting some biomed shops here around Houston. And every once in a while, I'll go out with the sales reps, and I will go with them and visit hospitals. And it's like random surprise. And the cool thing is, honestly, it's such a cool thing. We walk in, the sales rep and I, he doesn't tell them that I'm coming. And when people actually recognize me and they talk about like some of the videos that I've done and stuff, that's so rewarding. It's so cool at the same time, having that kind of effect on people. But I love those reactions when I walk in the door and they're like, hey, wait a minute. And I absolutely dig that. And I love talking with biomeds in the work environment. You know, they show me some of the cool stuff that they're working on right there. So maybe I'll be able to do some videos this week and in the future as I go to some of these biomed shops, walking around, meeting people, discussing what they're working on. And eventually I'd also like to start talking with them about some of the complications, some of the hardships that they're facing. That's one of the topics I'm going to probably get into soon, is because every hospital, they have like unique hardships, like manpower, or, you know, ordering parts is complex, Phobie Now app. You know, there's lots of different things that you can do, but I want to bring you guys what it looks like inside certain biomed shops. Some of them are beautiful. Some of them just need love. and the ones that need love, I would love to be there to help them. Like, let's tear some of this stuff up. Let's check it out. So eventually, anyway, some of that's the goal. Guys, I'm going to end the stream right here because today was a success, and I know if I continue streaming, I'm going to mess something up. And I do not want to do that, all right? So anyway, guys, I'm going to go in and, well, I don't know. Maybe I'm going to go check out some rum and then chill out and maybe put the baby in bed. Sounds like a plan, huh? Thanks for watching, guys. Do appreciate it, and I love the support that y'all are giving me. I sincerely appreciate that. Honestly, I do. So thank you very much, guys. In the last week alone, I have like 900 new subscribers. Guys, I am so enthused about that because most of those people are people that did not know that this career field exists. And guys, I absolutely love that we're showing this career field to new people. We need some help, y'all. We need some help. We don't have enough people that do my job. Biomed here in the United States, we need some help. So if you're interested in becoming a biomed and you currently are not, check out cbet.edu. That's the College of Biomedical Equipment Technology.edu. And check them out. They have certificate programs. They have degree programs, various types. They even have a 4-year degree. And they also do other certifications. If you are a biomed, check them out because they have new certification programs. More is going to come on that soon. They have reached out to me very recently, and we kind of talked about some of our plans and how we're going to help each other. But we got some cool videos coming up. Stay tuned, guys, all right? Thanks again. Y'all have a nice night, all right?